Here we have a pump trainer. We have an electric motor with a horsepower meter through a magnetic coupling to a centrifugal pump. The pump itself is made of acrylic, so we can see the spinning impeller inside. We can also see the fluid go through. It's got a gate valve here on the discharge. It's got another valve over here on the suction. And all the piping here is clear, so we can watch the flow of fluid. Right now it's all clear water, so we can't see much in that regard. It's got a rotometer here showing us the amount of flow. But what I'm going to demonstrate here is cavitation. We're going to purposely cause cavitation to occur in the system. We're going to do so by keeping the discharge valve wide open like it is and pinching off the suction valve. What that will do is reduce the pressure in this line, and you'll see this compound gauge show a stronger and stronger vacuum as we begin to pinch off this valve. Now I'll start to turn this clockwise, and you'll see the gauge's indication go down. You'll also begin to hear cavitation take effect, and we'll be able to see the bubbles form inside of here as it cavitates after it flashes in the vapor and cavitates into liquid again here. So here we go, closing the valve. And watching the gauge. The gauge will go down. Minus 10 inches of mercury. Minus 12. Minus 14. You can start to hear flashing occur there. 16. More noise. Minus 18. Minus 20. You start to hear that sound that sounds almost like rocks going through the pipe. There's no debris, there's no solid material through here. That solid sounding sound is really the collapsing of the vapor bubbles as they go back into liquid form. You can really hear it now. You can see it occur inside of here. It's a very pronounced action and noise. As the water goes through the valve, it reduces pressure going through the restricted valve. Its pressure drops below the vapor point of the water at this temperature. It flashes into steam, and then after it comes out of the valve and expands again, the pressure goes up, and what happens is those vapor bubbles collapse back into liquid, and that's when we get the cavitation effect. We can see it happening here. We can also see some bubbles here in the scroll casing of the pump. Cavitation is very destructive, especially upon metal surfaces. The acrylic surfaces here seem to handle it a little bit better, but with metal surfaces there's no give, and it's very destructive. The metal will become pitted by the high pressure jets formed by the collapsing bubbles. So I just want to illustrate what cavitation looks like in an acrylic tube and what it sounds like. It sounds like rocks, literally like rocks going through the pipe. And again, we cause it by dropping too low of a pressure, causing flashing to occur, and when the pressure rises again, the bubbles collapse, and that's when cavitation occurs. I will open this valve back up. That increases the pressure on the suction side of the pump, less and less vacuum, until we no longer flash, and we no longer cavitate. And that's a happy pump.